Good morning, everybody, and welcome to our first breakout session today. I hope everybody enjoyed this morning's keynotes with John. Again, I'm Bill O'Dell, and I'm the Chief Marketing Officer here at Aerospike, and I will be introducing you to our next speaker. Before we do so, I wanted to let you know that you can ask questions, and to do so, you just look to the left-hand side of your console and look for the question mark. And at any time during the speaker's remark, please click on that icon and you'll be presented with a window where you can submit your question. I will be looking those questions over during the course of the presentation. And at the end, I will be asking those questions of our speaker. So sit back, relax. I hope you enjoy our first breakout session of today. So with that, I want to introduce you to our speaker, Venkat Thamminana. He is the Vice President over the Portfolio Management Solutions at Charles Schwab and Company. We're delighted to have him here. It's the first time we've had a presenter from Schwab at our user summit, so we're thrilled to have him today. He's going to spend the next few minutes talking about how he helped Schwab develop a number of use cases in the portfolio management area of Schwab's business and how he did that in a very high scale manner. So with that, I'm going to turn it over to Venkat. Venkat, the show is yours.
Thank you, Bill. Thanks for the introduction. And good morning, everyone. As Bill mentioned, I'm Venkat Thamminana from Charles Schwab. I'll be covering our Schwab journey in last 7 or plus years on developing highly scalable applications at Schwab for next 30 minutes, and we'll keep for last 10 minutes for Q&A session. So we started this journey in 2013 when a majority of our legacy applications were on mainframe, and there were some distributed applications as well, some portion of applications. But we had 3 issues that was hindering our business. The time to market, it is taking longer time when we are developing those applications on mainframe. The issues are many, like the identifying the talent was tough, and mainframe being the way it is written, not multiple teams can work in parallel. We cannot componentize the applications, and it is becoming a lot costlier. Time, money, and scaling. Scaling is another bigger problem. Mainframe is very good at scaling in many ways, but it comes at very steep price. The way mainframe licensing fees is, it's not easy to scale like what we can do on distributed side. So that was the background in 2013, and we wanted to modernize our applications in portfolio management. Portfolio in my org, we manage most of the front-end client-facing trading functionality and majority of the back-end posting system. So a lot of critical components are served out of client-facing, and the whole back-end components are served out of mainframe. That's where we started our, we wanted to come up with a strategy where we can build, our goal was deliver faster, cheaper, and highly scalable solutions. All these 3 were having a problem when we were on legacy. And the outcomes we expected from this initiative was we should be having ultra low latency response for all the services that we host, and they should be linearly scalable, horizontally scalable, and highly available. Availability is one of the bigger concern too. For all the things that constraints that mainframe is having, it is highly available. We can always count on mainframe availability, and we wanted to bring the same level of availability onto the distributed side. So in 2013, we started with capturing our target architecture, and we one of the things we wanted to have is there are n number of backend systems, which are systems of record that needs to be queried as part of the client interface, and that is where the latency was getting a big hit, where we need to query each and every system. And in some of the login calls, we need to call some 20 different systems to get the data and present it to customer. So we wanted to have a cache layer where we can cache all the data and keep it at one place, so that when customer request is coming, we look at one place and get the data. And that's where we did a POC. We looked at all the NoSQL databases that are available in the market at that time in 2013. And for our use case, Aerospike, we identified Aerospike as our solution. In the POC, the key capabilities like horizontally scalable and ultra low latency. Even in our POC, when we did on regular VMs and attached to NAS, it was performing quite well. The latencies are less than 1 millisecond, and in the VMs, it usually is less than 2 milliseconds, almost 99.9% of requests. So that's the context where we started our 2013 journey and identified Aerospike. And I'll walk you through 3 different use cases where we implemented leveraging around Aerospike, leveraging capabilities of Aerospike. I'll move on to the next slide. So this is, we first targeted read applications, Aerospike as cache. So what we meant here is legacy, the leftmost corner, this is where the legacy applications were. They were handling both the read request as well as write request. Every time there is a read, when a request is coming through a channel like Schwab.com or a mobile channel, that request is hitting, we are querying, we are making calls to all the legacy applications. As I mentioned, some 20 legacy applications that we need to call, and then render the response back to the request. So we wanted to have migrate the read applications, and majority of the requests are reads. Customer wants to know how their portfolio is doing, what is the gain, loss, what is today's market, how their portfolio is performing today or compared to prior day or prior week. A lot of reads will be there, and writes will be there when customer wants to do actual trading. So from that perspective, we wanted to migrate our read is a lot of load. When we look at our stats, typically 80% of requests are reads and around 20 are writes. So read is putting a lot of stress on the legacy system, as well as it is also impacting direct client experience. So we created this, we set up Aerospike clusters, and we built this Aerospike integration layer, which essentially talks to the systems of record whatever the legacy applications are writing to the database, mainframe writes to DB2, and there are distributed applications that are writing to SQL Server. And we also have data warehouse on Teradata. We've identified all the source systems, and we worked with the applications to get the data into Aerospike, near-time replication. Like when some of the applications were providing flat files at the beginning of the day, and they're publishing events throughout the day. So we created two capabilities on this integration layer. One is the message processor. So this is hearing to all the different types of events that are generated by the write applications. And then there is custom ETL loads, which are at the beginning of the day. We get the full extract of all the data and we load it into Aerospike. So the expectation is the data in Aerospike should be reflected near real time, what is there in the system of record. Once we are able to get the data into Aerospike and put it in a format that is consumable format, we are storing that the whole application layer we developed in .NET. So we stored the objects in .NET format within Aerospike. And when we are querying Aerospike, like we leveraged those two capabilities. One is we are able to get in .NET format and leveraging the NoSQL feature. Like there might be 10 tables in RDBMS in DB2 or SQL, but we are able to consolidate all those things into one set, or most of the time we are able to accommodate into one set, because as long as primary key is same, we can enhance, add more bins and accommodate that. So those two things we leveraged while writing the data into Aerospike, and that provided us a ground where we can build any number of read applications as long as the data is in Aerospike, because the backend, the MQ processor and file processor are taking the bulk of the load to keep the data in sync. So whenever there is an issue with the data, we need to look only in these two components, the message processor and file processor. Otherwise, we are immune from what changes are happening in legacy applications, or what changes are happening in the client-facing application layers or services layers. One of the big use case we are able to solve in this way is, as you know, we have at Schwab we have 13+ million accounts, and we render loans to our customers as a margin loan or loan against a portfolio. And that is one of the biggest income earners for Schwab, the interest on such kind of loans. So for that we were unable to offer more custom loans and more competitive prices on the loans, because our systems were not able to handle the risk very well. So we wanted to build a system that where we can monitor all 13 million accounts in more real time, and escalate the orange accounts and red accounts only to our operations team so that they can act on it quickly. So for that 13 million accounts, and if we are monitoring on 5-minute intervals, that's a lot of stress on the database. And there are various types of risk management tools we need to monitor. So it is not we can't get the data once and run all the queries, but there are various processes we need to handle: option expiration risk, margin risk, the credit risk. So multiple processes we are able to run in this application layer, and we are able to detect the accounts that are getting into that are in state a lot earlier than they will go into red state, so that we have opportunity to work on those accounts and recover the money without losing the principal. So that is the way we handled. The first application we looked at is the credit risk management system, and after that we worked on many. We deployed many of the read applications onto client-facing read applications onto that layer, like how to fetch transaction history, service to fetch portfolios, service to fetch market data. Everything we are able to embed here into this application layer. One thing I'll add is most of the data that gets stored in Aerospike in this use case, some 80+% of data is refreshed on daily basis. So when the legacy systems run their batch jobs at the end of the day, we fetch the data and overwrite what is there in Aerospike so that we are ready for the next business day. I want to call out one to support when data is getting refreshed, customer should not see inconsistent experience. We created that blue-green kind of sets. So if we are having refreshing, I think there are some 15 sets that gets refreshed daily. So we created 15 active sets and 15 inactive sets, and we'll be on a given day, one set would be active, and we'll be loading the data into inactive sets. And when the data load is complete, we'll switch the sets. Active will become inactive, and inactive will become active. That way, we are customer experience is always consistent, and all the transaction processing, everything is applied on the right data set. So that's on the read applications. I want to call out what business kind of we talked about. Client interaction is now independent of source system availability. This is one of the biggest things we are able to achieve. During intraday, if source system is there is an outage for a while, customer is not impacted, and customer experience is totally independent. And scaling, this is where the real value. We are able to scale the application layer quite well. It's like we deployed in private cloud, and we can add more instances, and Aerospike is the backbone of our scaling infrastructure. We can scale it easily by adding nodes. So we are very much up to speed, whatever the load on the system. So we always supported 4x load to handle. And it is reflected when we had this corona scares. Market went very volatile. Our systems are very stable, and we never had an issue with latency or performance during this time. This is a big validation of all the efforts we put in modernization. The latency is one of the best. Now we are talking about at every service level, we wanted to hold to 30 to 40 millisecond latency, and we are able to achieve that on this in this architecture. Whatever services are built, we are sticking to that 30 to 40 millisecond latency. We are performing over 13 billion queries against Aerospike in a typical day, and it's great to see 99.9% of requests are returned within less than 1 millisecond. That's the real secret sauce behind that low latency performance. And we went live with the first application in 2005, and in last 5 years we made a lot of progress on building many applications on this layer. So that is on the read and I'll cover the write. So in the first use case, when we are moving away all the read applications onto new modernized layers, the writes are still handled by the legacy application, and whenever an update is, whenever there is a change in the data, a legacy layer is publishing an event, and on the distributed side, we are subscribing to that event and updating the data. So now these write applications are when customer places a trade, places an order, and we execute the trade. The whole thing is write. It will be customer balances will be updated, positions needs to be updated, portfolio, profit and loss, everything needs to be modified. So that is, we wanted to move that write logic. Write is a lot more complex logic than read. So we wanted to implement write applications onto the modern layers. So we are updating that in the target state. We are updating Aerospike in real time, and it is the reverse. Every time there is an update to Aerospike, we are also publishing an event to legacy system through asynchronously. Like we are writing to a queue, and there is a drainer process that will update the source system or system of record. So it is a reverse paradigm of read application. Aerospike is it will get data at the beginning of the day, and this write application will read the data from Aerospike, and it will write the data into Aerospike within the same transaction. And asynchronously, it posts the message onto the MQ, some messaging queue we are using, because most of the applications are mainframe applications. We are using IBM MQ, but we are also will also be using RabbitMQ and Kafka for the going forward, as long as the other legacy system is a distributed system. So this is here we are using Aerospike in a true operational data store. During intraday, Aerospike is our system of record, and here we are getting the benefit. Even source system is not available, there is an outage or the latency or anything, customer experience is not impacted. It is written asynchronously, so source system is not available. Messages will queue up in the queue, and when it becomes available, everything will be written. But in this system, in this architecture, or in this use case, system of record is still, we are keeping the system of record as source system of record, either mainframe or DB2, because this data is leveraged by a lot of other applications. So we wanted to make sure data is available intraday as well as end of the day, so that all the downstream applications will work as expected. Here are the benefits. So we are availability, client experience is improved. We are not depending on any of the source systems. Only Aerospike and middle layer availability is what we are looking for. Aerospike has become true intraday system of record, and we went live in 2018. And this process we are working on. We are migrating many applications onto this architecture. The next slide is about this is extension to both the use cases. When we are building new capability which is not supported on legacy, that's when this use case would be applicable. So we don't need to write to legacy anymore, because this functionality is not there in legacy. So we don't need to write to any system of record. So instead, we made Aerospike as our system of record. So both the reads and writes are managed by Aerospike, by the modern layers. But Aerospike is also acting as a system of record. So in this scenario, there is no refresh of data, no, we are not keeping the data in sync with any of the system of record, because Aerospike is the system of record, and anyone wants the data, they can directly fetch the data or a service or through directly accessing Aerospike depending on the use case. And we are working on one of the project where the data retention period and the amount of the data stored is huge. So when even a typical use case, this is a very good use case, but when the data retention and historical data we need to store is higher, then Aerospike makes a lot better use case. In one of the projects we are working on, we plan to store over 500 terabytes of data in readily available, accessible data. And that's where we worked with Aerospike to come up with a hardware strategy on how we can store that kind of data. And surprisingly, with the latest hardware improvements that have come on, we can find disks up to support that up to 6 terabytes in one disk, and we are able to come up with a pretty small footprint to store that huge amount of data, while we are getting all the benefits of low latency. Of all the historical data that is available, we can query real time, and we are able to keep up with our SLAs with the customer channels. So this is kind of a evolution on our modernization journey. And in all these three use cases, the right use case is one of the complex use case where we need to support all the asset properties, and we are dealing with customer money. Every transaction, everything customer places, we need to make sure there is never an overwrite or any exception or any wrong data getting posted. So it's that's a pretty tough use case, and we are happy to say we went live in 2018 with our core post-processing engine, and it is working perfectly well. We never had had an issue where customer complained and something not processed correctly on the backend system. So it's a true reflection of capabilities that Aerospike provides and how we are able to leverage those in the application layers. So this is the last slide in my deck. This is the business capabilities that were delivered with this third use case. Making system of record is comes with a lot of responsibilities. We should be able to back up, recover real time, how we can get real time access to all the data. It's a pretty we need to think a lot on all the things that are offered by typical RDBMS use cases in backup and recovery process, and we are able to emulate all those capabilities using capabilities provided by Aerospike in their last 4X version. We are leveraging all the capabilities like rack-aware clusters, the XDR capabilities, because we are running in multiple data centers, and within each data center we have multiple network cores. So we are running a no shared architecture in the terms of deployment. So whatever happens in one data center or one network core should not impact anything on the other data centers. and leveraging those capabilities, particularly rack and XDR, really helped us to get to the point where we are able to support those no shade architecture at the same time providing all the latency and availability requirements. So those are the things I thought of sharing with you. This has been a very exciting ride at Schwab for the last 7 years. Now it came very handy when Schwab acquired TD Ameritrade. The scalability is on top of our agenda right now across every org, across every application. And we are, whatever applications we migrated over into this architecture on these 3 use cases, we are so confident it is only adding more hardware is what we are looking at. Otherwise, we are so confident this will scale as much as needed as long as we cover on infrastructure side. With that, we are ready for question and answer sessions. I think we have 8 more minutes for question and answers.
Well, thank you, Venkat, for for sharing that information with everybody very clearly and cleanly and openly. So I'm sure everybody appreciated that. We do have a number of questions that have come in through the chat, so I'm going to open those up and read them to you rather than try to interpret them. So I'll start in the first one. You might have explained this, but because this came in kind of early, but I'll ask it anyway. Is this system now a system of record that also supports real-time transaction systems?
Yes, in use cases 2 and 3, Aerospike is system of record. In use case 2, when write applications are migrated, during intraday, Aerospike is system of record. And in the third use case, Aerospike is the system of record, intraday or any time of the day.
Okay, thank you. I think you stated this, but probably worth clarifying. The question is I am assuming you are using strong consistency mode. How are you handling the 500 milliseconds per node time to detect the new master partition for read-write processes?
Yep, we are using strong consistency. That is one of the key requirements for us. Requests can go to any data center from customer, but they should be seeing a consistent data. The way we handle that write consistency is we are able to we split our write load across 2 data centers. Half the accounts are handled by one data center, other half are managed by other data centers. That way, we are trying to avoid those collisions. Same account updated at both data centers at the same time. Instead, we split the traffic and leveraging XDR to keep the data in sync. So anytime we are writing to a data center, in real time, we are only talking to one Aerospike cluster, and still we are able to retain those low latency things. 99.9% of writes are taking less than 1 second, right at set level. So we are still, I mentioned with the recent enhancements we have promoted, we are handling a very complex transaction which will write to more than 15 sets. We are still supporting 20. I think right now the average is 23 milliseconds to write a transaction. And 95 percentile is about 45 milliseconds.
Okay, thanks. I'll read the next one in order. Could you comment on the challenges you faced integrating Aerospike with DB2 and other systems for read-write processes?
So in the write process, it's a very we detach it from Aerospike. It is an offline process that is writing to DB2. So application layer is the one that is responsible to writing to system of record. Application layer, at the time of writing to Aerospike, if the Aerospike write is successful, the message is published onto a queue. And there is a drainer process which is written in .NET that actually connects to DB2 or SQL Server and updates the system. So we move that traffic or that responsibility onto application layer. I believe now Aerospike has come up with plugins with Kafka and other things. Maybe those are the things that if we are working on implementing now, those are some things to look at, leveraging Aerospike capability to publish those events and sync up with the system of record.
Terrific. Next question in order is, what type of storage layer are you using? Hybrid, NVMe, flash?
We are using, we are not using hybrid yet. The primary keys are always stored in memory, in RAM, and we are using NVM disks. We started with Micron SSDs in 2014. That was very low density. I think that each disk was storing about 700 gigabytes of data. And we deployed a new cluster in this year, at the beginning of this year, that came with Micron NVM disk, which can support up to 6.2 terabytes.
Okay, thanks. You expect about 500 terabytes of storage in the future. How much data is being stored right now in Aerospike?
That application, we are going live in Q4. We are looking good at this point. And when we go live, we'll be storing about 120 terabytes of data we'll be starting with, and we'll grow to 500 in next 5+ years.
Okay, great. I'm just going to read this one for you because it's a compliment, I think, to your presentation, Venkat. It says, thank you for an excellent description of your journey. My question, there is a lot of work your application teams must have done to enable the transformation of the previous application data models to the Aerospike data model. Can you share some of your experience in this area?
Yes, that's a good question. Building that Aerospike integration layer, that's where the real challenge is, how we get the data from source system, because we need to work around capabilities of source system. We can dictate this is the way we want it to get. And we are dealing with mainframe systems where you can't ask questions as you want. You have to think through their perspective, what they can do in a short period of time. So what we try to do is we try to retain the same data structure as in DB2 into Aerospike. So we translated, if one table is there in DB2, we translated into an object of key value pairs, and we stored that object as is in a bin in Aerospike set. That way, anytime we wanted to refresh the data or sync up the data, it is very straightforward. There is no logic involved in mapping. It is one-to-one mapping. Like there is, just for example, there is one account that can hold n number of positions. So all the positions are created as a list and stored into one bin against that account primary key. That way, you want to refresh positions. We get all the positions from source system and refresh that bin. And that also makes it easy, made it easier for us to troubleshoot if there is a data issue that some account is having. What could be the reason and why that discrepancy happened, and where to look for correcting that.
Terrific. Well, we're going to run out of time here, so I'm just going to read off. This is more of a comment than a question, and I think others will join me in this sentiment. And it says, this is the best talk of the summit so far. So with that, I'm going to thank you, Venkat, for your time today, and thanks everybody for joining us. And I'm going to welcome you all to move on to the next session as I say, thank you for joining us today.
Thank you. Thank you, everyone. It's great to share our experience. Have a wonderful summit.